All right, welcome to today's class. We have 3 to the power of 4x raised to the power of 2 minus 4 to the power of 3x equal to 0. What is the value of x? Okay, I asked to look for the value of x here. So here we take our solution. All right, so again, the question is 3 to the power of 4x. X is raised to the power of 2, then minus our 4 to the power of 3x equal to 0. The first thing we're going to do here, because we cannot factor out any of the constants from here. And so we move this to this side of the equation. So we have 3 to the power of 4, x to the power of 2 equal to our 4 to the power of 3x. All right, so yeah, this cannot be broken down beyond this, but we can reduce this to 2 as a base. So we can write this 4 as 2 to the power of 2. So this is going to give us 3 to the power of 4, our x to the power of 2. This is equal to our 2 to the power of 2 into our 3x. Then if we multiply, then we're going to have 6x. Give us here 3 to the power of 4, x all to the power of 2 equal to 2 to the power of 6x here. So at this point, we can take log to both sides of the equation. We can log both sides of the equation. In other words, let's take log to base 10. Okay, so we have here log our 3 to the power of 4, x raised to the power of 2, base 10. This is equal to log our 2 to the power of 6x base 10. So applying the power law of logarithm, we say that if you have your log, your a to the power of b, so this is b times log your a. So we can move these to this side, we move these to this side. And so if we do that, then we're going to have our expression to become here we have 4s to the power of 2 times our log 3, then base 10 equal to, we do same thing here, so we're going to have 6x times log 2 base 10. So we want all the x terms to be on the left-hand side. And so what to divide through by 6x here, and at the same time by log 3, so that all the constant terms will be on the other side. And so this is going to give us here our 6x times our log 3 base 10. Then we equally do same thing to this other side, our 6x dividing times our 3 is 10. Okay, so this and this will leave, then this will leave. So we're now left with our 4x to the power of 2 all over our 6x will now be equal to our log 2 base 10 all over log 3 base 10. Wow. So from here, look at this. We can separate this constant from this variable. So we have this to be 4 all over 6 times our s to the power of 2 all over x. This x is to the power of 1, right? Good. So this is equal to, here we still have our log 2 base 10, then dividing log 3 base 10. Okay, now 2 can divide this, 2 can divide this. And so here we're going to come up with about 2 all over 3. Yeah, because 2 here we have 2, 2 here we have 3. Then if we apply the division law of indices, which says that if you have your a to the power of your m, then all over a to the power of your n, said take only one of the base number, then you have to subtract the exponent. So if we do that, this is going to give us just x. So we're going to have x here because this is going to give us x to the power of 2 minus 1, right? Good. So this is equal to our log 2 base 10 all over log 3 base 10. Wow. We are looking for our x. So we divide through by 2 all over 3. We equally divide the whole of this by 2 all over 3. Okay, so with this we go with this. So we now have our x will now be equal to, we change this to multiplication sign. And so this goes up, this comes down. So we're going to have this to be our 3 all over 2, then bracket. Now look at the whole of this expression here. I want to change from base 10 to base 3. So if we do that, this is going to give us log 2 base 3. Yeah, okay. So this will be our answer. What is the law I just applied? The law which says that if you have your log, your p, right, p base k, let's say base k, and you want to change to base q, this is now log your p base q all over log your k base q. Okay, this is what we call change of base law, right? So if you do that, this becomes your final answer. So this is your x. All right. So thank you for watching. Thank you for staying back. See you in our next class. Bye for now.